prototype geometry was planned to allow for a great configuration space and avoid large disturbances coming from gravity. Motor 1 is placed at a relative height from the horizontal plane, allowing for a vertical offset. Motors 1 and 2 orientations were chosen to avoid disturbances in the rotations due to gravitational torques sharing the same axis as it is the case with vertical arm. Two 3D printed X-beam pieces were designed for having a symmetrical moment of area in any horizontal orientation. Horizontal displacement is achieved by 176 and 246.5 mm links being rotated with respect to the vertical axis by motors 1 and 2. The third motor is used for controlling the end effector's height, having the third link attached to it with a free rotation joint, which allowed for the angle adjustment of the end effector posed by gravity. Finally, the end effector geometry corresponds to a domino housing tool with the fourth motor rotation axis along its centroid. The defined workspace is a 765 by 502 mm planar rectangle. The origin of our reference frame is at 300 mm from the left of this rectangle and 472 mm from the top. This workspace is divided into regions for different purposes. At the beginning, dominoes are placed on the domino insertion space in a random order. The domino's end position is located at the left of the plane, and, as its name suggests, it is the place where dominoes will be positioned once sorted. Dominoes are to be sorted in an ascending order, counting them as fractions, having the square with less pips as the numerator. When the 28 dominoes are sorted, a pyramid will be formed. If a domino being moved cannot be placed at its destination, it will be moved to the stack region, where it will remain until its final position is ready to be occupied. A path region is defined in order to allow displacement of dominoes avoiding collisions. Finally, an out-of-reach region was recognized due to physical impossibilities of the arm, also called singularities. For the project, the sensor position was chosen such that the camera looked down directly onto the workspace, resembling an orthographic top view of it. This was done to reduce the complexity of a 3D workspace to a 2D one. This setup allowed to perform coordinate transformation using the focal length to depth ratio and doing vector addition to establish the origin position. In addition, Kinect 2 was selected due to its high resolution with respect to the other options. Due to the geometric characterization of the arm as described previously, the inverse and forward kinematics problem was solved in two stages: a 2-revolute joint arm and the end effector angular displacement. The first one controls the position of the end effector, and the second one regulates the orientation, which allows us to pick, move, and place dominoes in any position that we are within the workspace. Furthermore, the Navitt-Hardenberg convention for the angular position and the joint reference frame was used for motion practically. You can see here that the angles and reference frames are θ1 refers to the angular displacement from the fixed reference frame to the rotated reference frame due to the rotation of the joint 1. θ2 is the homologous to θ1 but for joint 2. The case of θ3 and θ4 is special. θ3 is uniquely used for end effector height control, which allows us to pick and place dominoes. Theta 4, on the other hand, relates the orientation of the dominoes by the formula phi equals theta 1 plus theta 2 plus theta 4, where phi is the overall orientation in the workspace of the end effector. The algorithm was based on three basic motion functions that made the end effector move in straight, vertical, horizontal, and diagonal lines. Managing to do so was rather difficult, since the revolute joints do not easily generate linear motion. The approach taken was to discretize straight paths from one position to another, and then progressively follow it by going to each point of those paths. Given some physical limitations, the domino enters the path with one angular solution, until it reaches the middle of this one. At this point, it switches to its second angular solution, so that it is able to reach its end position. Finally, if placing the domino at its end position would block other paths, this domino is moved momentarily to the stack region, where it will remain until this condition changes.